In today's class, we will discuss the artificial recharging of groundwater. So let us understand what is mean by artificial recharge, because we nowadays we are facing the scarcity of water. So managing the water resources which we have, that becomes the essential criteria for managing the water resources. So here let us see what is mean by artificial recharge. So this artificial recharge may be defined as the process by which the infiltration of surface water into groundwater system is increased by altering the natural conditions of replenishment. So here what is done? Whatever surface water is available, that surface water is infiltrated into the groundwater system, and for what reason? That is to increase the natural conditions of replenishment of the water. So a wide spectrum of techniques that are in use for such type of methods, that is recharging of groundwater. So most of these are in the artificial techniques, and these are they vary widely depending upon the availability at the particular site. So what is mean by artificial recharge is, it is a method, or it is defined as a process by which the infiltration of surface water into groundwater system is increased. Okay, we have to increase the infiltration of surface water into groundwater by altering some of the natural conditions of replenishment. So we have to alter the natural things, and we have to recharge the groundwater. So that is called as the artificial recharging of groundwater. Now we'll discuss what are the different methods for artificial recharge. So the first method we'll see is basin method. So this is a very simple method. So this method involves the surface spreading of water in the basins that are excavated in the existing terrain. So here you can see in the diagram, there is a stream here, natural stream which is flowing. The water is flowing in this direction, and here we have to construct a barrier, or it is called as diversion structure, and this water whatever is flowing downstream, we have to divert here. Okay, so where we have to divert? Here we have to construct the sediment retention basin. So in the first basin, all the sediments will settle down, then the water will move into the next basin and the third basin, and the excess water will go again into the back into the stream. So the basin method involves what? Surface spreading. So we are spreading whatever water is available in the stream. We are providing more surface area, right, for the groundwater recharge. So the surface spreading of water in the basin that are excavated in the existing terrain. So here in the existing terrain, the basins are excavated and the water is allowed to flow into those basins. So the size of the basin, it depends upon the slope of the land surface. Then the infiltration rate increases with the depth of ponding. So as much as deep the pond is or the basin is, the infiltration rate will be more. So in alluvial plains, that is where the fertile soil of the river, okay, that is available, in such plains the water may be diverted into one or more basins which are constructed parallel to the stream channel. So these basins are constructed parallel to the stream channel. So the basins are constructed in pair or in series, and they are parallel to the stream. So the upper one, which serves as a settling basin for removal of the silt. So because here we are diverting the water, the velocity of water decreases, and whatever load the river carries, it will try to deposit in this basin. So the first basin will work for the sediment retention basin, that is to remove the silt which is present in the water, the fine suspended particles or the particles which settle down, those are removed in the first basin. Okay, then for effective artificial recharge, highly permeable soils are required, and maintenance of water layers above the soil surface is necessary. So this is how the basin method is practiced, wherein we have to construct the basins which are parallel to the stream. Okay, and first basin will serve as a sediment retention basin, and the water will flow into the next basin. We have to construct those basins in a series. So this is how we increase the groundwater recharge. Okay, then we'll move on to the next method, that is the ditch and furrow method. So here many ditches and furrows are constructed. So how it is done? So where it is done? In the areas with irregular topography, means the ground is not regular, it is irregular topography if it has, and it is shallow, and it has a flat bottom, and the closely spaced ditches and furrows are provided in such areas where the maximum water contact area for recharge water from the source stream or a canal. So here this is a stream. In the image you can see there is a stream in which the water is flowing in this direction, and this water is diverted here. Okay, and there are number of ditches which are constructed, right? So 1 2 3 4, then here is the 5th, 6th and 7 ditches are shown in the figure. So these are the ditches which are constructed. Okay, so this technique requires less soil preparation than the recharge basin. So for basin we need to prepare more, we have to construct the basins properly. Here the preparation of soil is less compared to the basin method, and it is less sensitive to silting also. So generally 3 patterns of ditches and furrow systems are adopted. One is the lateral ditch pattern, then dendritic pattern, and the contour pattern. So these are the different patterns of ditch and furrow method. Okay, so here the water from the stream is delivered to the canal. Okay, like small canals are constructed. Okay, so the water is diverted into small canals. So prevailing ground slope is generally greater than 3%. Okay, so like this small canals are constructed wherein water is diverted. Okay, and they are constructed in lateral ditch pattern. How it is done? The ditches are made at right angles to the canal. So the rate of flow of water from the feeder canal, that is the main canal, okay, is controlled by the gate valves. So here you can see there are gate valves which will control the entry of water into the canal or ditches. So the furrow depth is kept according to the topography, and also with the aim that the maximum wetted surface is available along with the maintenance of uniform velocity. So here the velocity plays an important role. So the excess of water is routed to the main stream through a return canal along with the residual silt. So again there will be a return canal which will send the excess water into the stream. Then in dendritic pattern, like branches of a tree, that is called as dendritic pattern. So water from the stream is diverted into main canal to a series of smaller ditches which are spread in a dendritic pattern like a branches of a tree. So ditches are spread like a branches of a tree. So the bifurcation of ditches, it continues until the practically all the water is infiltrated into the ground. So if it is constructed in this fashion like branches of a tree, then it is called as a dendritic pattern. Then there is one more pattern which is called as contour pattern. Contour. Then one more we have is dendritic. Okay, and one more what we discussed is lateral. Okay, lateral ditches, dendritic ditches and contour. So in contour pattern what is done? The ditches are excavated which are parallel to the contour, following the ground surface contours of that particular area. So maintaining the natural topography of the ground, the contour pattern is constructed. So when the ditches comes closer to the stream, a switchback is made, and thus the ditch is made to meander back and forth to transverse the spread, that is spread of water. So at the lowest point at the downstream, the ditch will join the main stream. So thus the water, excess water will return back to the stream. So this is how the ditch and furrow method will work. Then the next method of recharge is channel method. Channel method. So here again we are increasing the surface area. So in the image you can see this is the main stream. This is the original flow of the river. Okay. This is the original flow of the river. Okay. I'll show you once again. Yes, so here you can see the dotted one, that is the original flow of the river, and what we are doing now, we are constructing the dikes, okay, like a barrier structures. So because of this, what happens? Wherever there is a dike, the river will take a bend. It will take a bend and it will flow in a zigzag manner. So this is done again artificially. So distribution of flow by widening and leveling and lengthening of the stream. So the length of the stream also increases, right? By doing this, here you can see it was only this much, but because of the diversion in the track or the channel of the river, you can see the river widening, lengthening. Okay, and the channel will enhance the recharge of the water. So the stream should be influent and the stream bed material should be permeable. The material which is there at the bottom of the stream, that should be permeable, and the width of the flow may be increased by constructing a series of check dams or the bunds of small height. You can construct a small bund or a check dam, that is called as a dike. Okay, so an effective way of lengthening the flow channel is to create a series of dikes from either bank, that is on either side of the bank of the river. You can construct a series of dikes, okay, like a barrier, okay, which are extending about 3/4 the distance across the stream channel in the manner how it is shown in the image. So this is done in channel method. So this will lengthen the stream, okay, it will widen the stream, and as a result what will happen? The surface area of the water increases and there will be more groundwater recharge. Then the next method is pit method. So in pit method, where the areas have the permeable formation which underlies impervious soil. So if there is a permeable and impermeable series of rocks. So a pit or a shaft that has to be excavated to expose the permeable formation in order to make the recharging feasible. So here the pit method is practiced where there is a this is impermeable and this is permeable layer. Suppose then if it is impermeable, it will not allow the water to percolate. So what we have to do? We have to remove this particular portion so that the groundwater will or the water will enter into the permeable layer. So that is done in pit method. So in areas where permeable formation which underlies the impervious soil, the pit method or shaft has to be excavated to expose the permeable formations in order to make the recharging feasible. So the recharge pits are usually provided with a layer of filtering material for the protection against the silt which will enter through the along with the water into the pit. So to avoid that, we have to provide the filtering material. So this is the cross section of the pit, okay, wherein the water is recharging into the ground, and this is the top view where we have more number of pits which are constructed. So this is how the pit method will increase the recharge of the groundwater. Then next method, is the flooding method. So in flooding method, what is done? The water is spread as a thin sheet over the agricultural land. Okay, the water is spread over a agricultural land to a depth of few centimeters to a meter or more, depending upon the nature of the ground, nature of the terrain. So this method is more suitable for relatively flat ground, flat terrain. Wherever we have there, the flooding method is practiced. So unlike other methods, no land preparation is required for flooding method. Just we have to spread the water over the agricultural land, that is in a thin sheet. That is called as flooding method. Then we have induced recharge method. That is, the term applies to a process of diversion of surface flow to the aquifer. We are inducing the water to get recharged into the groundwater aquifer. So it is an indirect method of artificial recharge which involves pumping from the aquifer hydraulically, which is connected with the surface water, and to induce recharge to the groundwater reservoir. So this method does not increase the amount of groundwater in storage, but what it does, it will permit the withdrawal at the higher than the normal rates. So that is practiced, that is induced recharge method, wherever the hard rock areas are available, where the wells are abandoned, where they are not yielding water. So in such site, induced recharge will be helpful. So the greatest advantage of this method is that under favorable hydrogeological situations, the quality of the surface water generally improves because the path through the aquifer material before it is discharged from the pumping well. So because of that, natural filtering take place, and that is how it will increase the quality of the groundwater. So that is the induced recharge method. Then the next method is the recharge well method or inverted well method. So recharge well method, what happened? This is one of the method which is used for the purpose of increasing the groundwater supply for feeding the surface water into the aquifer. So it is also called as inverted well or diffusion well recharge method. So the recharge rate, it depends upon the specific capacity of the well. So, and the availability of water and the depth of the water table in the particular area, and also it depends upon the available pressure head. So this method is more suitable in urban and industrial areas where we face the scarcity of water. So there we can construct the recharge wells. Okay. Then the next method is dug well recharge. Again, same dug well is constructed in the alluvial areas where the fertile soil is present. Okay, as well as even you can go for a dug well recharge in the hard rock areas. So there are thousands of dug wells which have either gone dry, or the water levels in the well, they have declined because of the removal of the water continuously. So to avoid this, the dug wells can be used as a structure for recharging the groundwater. Such abundant wells which are already dried up, such wells we can use for recharging of the groundwater. So groundwater reservoir, or the storm water, or the tank water, or canal water, whatever is available, the source of water in the area, that can be diverted into the structures to directly recharge the dried aquifer. So by doing this, what will happen is the soil moisture loses during the normal process of artificial recharge, that is reduced. So the recharge water is guided through a pipe to the bottom. Okay, so whatever water we are sending, that is sent through a pipe at the bottom of the well, so below the water level, to avoid the scoring of the bottom at the entrapment. So naturally, if you leave the water, what will happen? There will be scoring of the bottom, that there will be erosion. Then to avoid that, we have to send the water through a pipe. Okay. Then the entrapped air bubbles in the aquifer, that also may cause a problem. So to avoid that, we have to use a pipe. So the quality of source water includes the silt content should be such that the quality of groundwater reservoir is not deteriorated. So that is how the artificial recharge or dug well recharge is done. So a pipe is used here. You can see in the image, the water is recharged through a pipe into the groundwater aquifer. So this is the natural water table, and we are sending the pipe below the water table. Okay. So this is how the artificial recharge is done using the dug well which are already dried up. Okay, to increase the groundwater reservoirs. So whatever storm water or canal water is there, you can divert into such wells to increase the groundwater recharge. So these are all the different methods of artificial recharge of groundwater. So as the definition says, in all the methods, what is done? We have seen we are altering the natural conditions of replenishment, and we are recharging the ground. So it is called as artificial recharge of groundwater. So these are the different methods for artificial recharge of the groundwater, which is a very, very important question from exam point of view. With diagrams, you can explain all the methods. Thank you.